Hi everyone. In this video, I'm going to be walking you through a new OCI native service called OCI Application Configuration. I will start with an overview of the service and its benefits. We will then touch on the main use cases that the service will help with and end with a demo that covers the key features. We'll also take a peek into what we have in store past GA. Let's get started. Today's modern applications typically consist of several distributed components and microservices, which refer to common configurations from different modules. Spreading configurations across components is hard to manage and sometimes leads to hard to troubleshoot errors during application deployment and runtime as well. In these cases, using a central configuration store for all the runtime configuration data becomes pertinent. This is where the OCI application configuration comes in. The OCI application configuration is a fully managed OCI native service that gives developers a scalable repository to securely manage software configurations, parameters, and feature settings. It helps separate configuration from the code so that these configurations can then be dynamically updated to alter application behavior and control state without having to rebuild, redeploy, or restart the application. This saves time and development cycles that would otherwise be spent on repeatedly building and deploying applications. This in turn also reduces application downtime. With this service, app configuration can be defined once and shared across multiple applications, dev environments, regions that share resources or references to the same things. Instead of maintaining these configurations in multiple different places or changing and updating them multiple different times, it becomes easier to maintain externally in one place and update it once. In summary, the OCI application configuration provides developers with a secure, reliable, and unified repository to manage their application configurations externally to the code. OCI application configuration provides two types of constructs. The one on the left we see here is properties, which are key value pairs that can store different parameters and values. And the second on the right here, which is feature flags that are booleans, and these primarily help with switching on and off features. So what are the benefits of using the OCI app configuration service? We already covered a couple of important ones. The primary one being that any changes to configurations can be made dynamically in real time or runtime, such that the app need not be rebuilt, redeployed, or restarted, saving time and ensuring that there is minimal or no app downtime in the process. Additionally, only changes to individual properties can be propagated to the consuming applications, while the rest of the configuration file remains as is. The other key benefit is that the OCI application configuration provides a central repository, which is a clean and simple way of defining and maintaining configuration separate from the code in one place. Let's move on to some use cases for this service. The OCI application configuration allows developers to maintain different environment variables in configuration file. For example, we can separate out endpoints that are required for development environment, test environment, production environment using the service. Additionally, the service helps developers implement different user flows for different user cohorts using parameters and feature flags. For example, different kinds of content or experiences can be showed for a free user versus a paid user. Another use case is that it helps implement region-specific application behaviors such as compliance flows or support for different languages. And another good use case is the ability to dynamically and temporarily control the log levels in an application based on the diagnostic need at that point. Let's say if you're troubleshooting and want more detailed logs for a specific period of time, it can be enabled and then disabled once the troubleshooting is complete. Next, let's look at a high-level workflow for this service. There are two parts to this. The first being the setup, where the admin or the developer defines the common configurations using the OCI configuration service and then references them in the application code via the SDK or the API. And the second part is to then dynamically update these configurations in runtime and have the application react to these changes. The application can either poll for changes from time to time, or we can have a push-based model where the application is notified of a change and the app then queries for the latest changes alone. This push or pull-based model can be implemented at the consuming application side based on the need and time sensitivity of the app. In the demo today, I'll be demonstrating a push-based model using notification event handlers. Let's look at this workflow at a high level before we go into the demo itself. Consider everything above this imaginary line here to be different OCI services and everything below the line to be the consuming application code. Now, let's assume that the developer has already defined configurations using the OCI App Configuration service and is referring to them in the application code. An example of how we can propagate changes to these application configurations to the code is achieved using two other OCI services, namely the OCI notification service and the OCI events service in this particular example. What we will do is essentially create a notification topic in the OCI notifications service and set it up to call the application callback URL on any activity on this topic. And then we will create event rules in the events service to push an event to this notification topic every time there's a change in an application configuration. Once this setup is done, the notification topic will receive events from the event service when a configuration is updated or changed. And in response, it will call the callback URL of the consuming application. The app will then use this as a trigger to fetch the latest values of the properties or configurations that have changed and updates its behavior as needed. Now, let's look at this with an example app. For this demo, we will consider this grocery shopping app that internally uses the OCI App Configuration service. If you observe closely, the Add to Cart button are all disabled and I'm not able to add anything to the cart right now. Let us see how this is defined on the OCI App Configuration service. So I'm logged into my Oracle Cloud Console and I am navigating to the application configuration service here. So I can see the list of configurations that I already have. So the one that you see here named Marketplace App Configuration is the file that my grocery shopping client app is actually referring to. So if you notice, this is the primary application configuration resource and it has a unique OCID associated with it. And within the configuration itself, we have properties which are key value pairs and feature flags which are Boolean values. So the cart enablement, which we just saw on the grocery shopping app, is controlled through this feature flag which is called enable cart. So if you notice, it's currently disabled and we're not able to add anything to cart. So let's edit this in real time and see how the application changes its behavior in response to this. So I'll say edit and hit enable feature flag. So now we see that the add to cart button is enabled and I'm able to add to cart now. So I clicked on adding 2 bananas and we see that the cart is updated. Let's go in and take a look and we can see this item here, right? So now we can go back to shopping and see how properties work, right? So let's say I want to add 2 apples to the cart as well. But here we see an error saying cart cannot exceed a capacity of 3. Now this is because the cart capacity is controlled via properties on the app configuration as well. Let's see how that works. So if we go into property here, we see what is called as a max cart capacity and it is currently defined at 3. So if we were to increase this to a different value, let's say 15. Now if I go back and add 2 more apples, we are able to add this to the cart as well. I also want to walk you through a couple of other key features of the service. The first one being the service provides the ability to import from existing application configurations and also export them as well. This ability becomes extremely helpful in allowing customers to replicate configurations for their applications that run in different regions. So instead of having to create configurations in different regions from scratch, developers can export an existing configuration into object storage by giving the storage bucket URL and the file name. And then once it's exported, customers can then use that exported file in the create flow to create a new configuration from an existing file. For example, how that would look is if I hit create application configuration here, I would give it a name and then I will click show import options and select file here and give the appropriate object storage URL to be able to create from a replicated file. Another key feature that I wanted to also call out is labels. So if you notice here, this max cart capacity property has labels associated with it. What that means is, let's say your application refers to a property by a certain key, but based on the environment that the application is running in, you would like to have different values to be returned. Then in that scenario, you can use labels to achieve it. So for example, you can see here that the default value of the key is set to 15. But if the label is passed along, such as test or staging, then these different values will be returned to the calling application. Therefore, labels in short allow you to add additional dimensions to your properties, such as app versions, user cohorts, or environments, etc. Another feature of the service is that it allows you to view historic property values and the ability to also roll back to one of them. For example, if we click on this button here called key history, we will be able to see a log of all the times that this particular property was updated with different values, with the timestamp and what value it was updated to, and the ability to restore to a point in time value as well. Some other key points to note about the service are that configurations can be created and managed by developer or admins via the console, the API or the SDK, and the application code can remotely access these configurations through the SDK and REST API. Additionally, Terraform support will also be available post-GA, and access to the app configuration can be controlled at the level of the configuration using identity policies. That concludes our demo. The application configuration service is now available in limited availability and will go to general availability in September 2022. We would love to get your feedback on the service so we can effectively shape our roadmap going forward. Some exciting features to look for post-GA are integration with OCI Vault and the ability to lock properties, that is, ensure a property cannot be updated unless some conditions are met. If you need additional details about the service or want to try the OCI Application Configuration service, please reach out to the team through the coordinates that you currently see on the screen. Thank you.